Hello, abstract algebra students. Now we will talk about double addition and double multiplication, but we will look at the associative properties. In this screencast, we will prove that double addition is not associative on R. Now that's a little bit surprising because double addition was commutative, but as it turns out, double addition is not associative on R. So double addition, which remember was A star B equals A star B equals 2 times the quantity A plus B, is not associative on the set of real numbers. Now, this leads to the question of how do we prove something is not associative? Because so far we've only proven things were associative. Today, that is. In an earlier lecture, we proved that subtraction was not associative. So let's apply the definition of not associative here to the set being the set of real numbers and the operation being double addition. So we want to show that there exists A, B, C in the set of real numbers such that A star B in parenthesis star C does not equal A star in parenthesis B star C. Now, okay, so in the last two examples, we had a for all quantifier. And when you try to prove a statement with a for all quantifier, you have to let A, B, and C be given. But remember, when you're trying to prove a statement with a there exists quantifier, it means you get to choose the A, B, and C. So I can choose any A, B, and C that I want, provided that this is true. So I'm going to try it once on just the simplest A, B, and C that I can find. So proof. Choose A equals 1 in the reals, B equals 2 in the reals, and C equals 3 in the reals. These are obviously numbers in the reals, so I'm not even going to include a sentence to justify why they're there. Consider the following calculations. Now, remember, when showing an equation is equal, you either have to reason the left into the right into the left, or both into the same. However, when showing an equation is not true, when showing two things are not equal to each other, you calculate the left-hand side and the right-hand side separately and show that you get different things. So that is what we are going to do now. We will calculate the left side and the right side independently of each other and show that they equal different things. So A star B star C, if I plug that in, is 1 star 2 in parenthesis, star 3. Remember, the parentheses tell you which operation to do first. So when it is parenthesized like this, I am doing 1 star 2 first. I am adding them and doubling it, which is the formula for double addition. So 1 plus 2 is 3, doubled is 6. That means 1 star 2 is 6. So this is going to equal 6 star 3. Now, let's do 6 star 3. Remember, double addition means we add them and double it. So 6 plus 3 is 9, and if you double that, you get 18. On the other hand, if I do these the other way, A star the quantity, B star C, this is going to be 1 star the quantity, 2 star 3. Now, remember the parentheses tell us what to do first. So we'll do the 2 star 3 first and replace what's in the parentheses. 2 star 3 means you add 2 and 3 and double it. So 2 plus 3 is 5, doubled is 10. So that leaves us with 1 star 10. Now again, we'll work this out. Double addition means you add them and then double it. So 1 plus 10 is 11. When you double 11, you get 22. As you see right away, these are not equal to each other. So therefore, since 18 does not equal 22, we may conclude that A star B star C is not equal to A star the quantity, B star C. And that completes the proof because we chose an A, B, and C to handle the there exists quantifier. And we showed that this equation was not true by calculating both sides separately. So we have completed the proof. And we will put a square there to end the proof. Now, what you might notice here is double addition is an operation that is commutative, but not associative. In high school, commutative and associative seemed similar because addition and multiplication were both commutative and associative. Division and subtraction were neither commutative nor associative. Later on, you'll see another example of an operation that is commutative but not associative. And you will also see an operation that is associative but not commutative. These should all tell you that commutative and associative are different properties. One study done by a math education professor, I believe at the University of Washington, found several percent of pre-service high school math teachers went into their student teaching thinking commutative and associative were the same thing, and one implied the other. While that's an easy misconception to have in high school because addition and multiplication both are true, subtraction and division neither are true, this should tell you that commutative and associative are different properties, and it is possible for one but not the other to be true. Okay, more to follow.